Okay, so you're going to click on the link above this video in order to access this activity. So make sure you click on that link, and you can use this video if you get stuck, or you can use the video to follow along with the activity. It's your choice. Okay. Okay, so the first challenge gives us an equation, a parabola that's been reflected vertically over the x-axis, and it asks us to add a range restriction in row 1 so the parabola only passes through quadrants 1 and 2. Okay, so a few vocabulary words we have to know. The first is range. I'm just going to actually type this in here. A range restriction means we're going to be restricting the y values. So I'm going to, since I already know I'm going to be restricting the y values, I know up here when I type in the restriction, I'm going to be using y is less than or y is greater than. And I want it so that the parabola only passes through quadrants 1 and 2. So a quick reminder of the quadrants. If we look at a graph like this, we have the y-axis, the x-axis, and it divides the coordinate plane into these 4 quadrants. So we have like the positive quadrant, the negative quadrant, the negative quadrant, and the positive negative quadrant. So what we call those is we just give them numbers so we can talk about the coordinate plane easier. So we call this quadrant 1. Sorry, I wish I could write on this right now, but this is quadrant 1, where everything's positive. The x's are positive and the y's are positive. Quadrants 1 and 2. And then down here below we have quadrants 3 and 4. So important thing for today is quadrants 1 and 2 are up here above the x-axis. We only want the parabola to exist in this quadrant and this quadrant. So just this part of the parabola, and then we want to erase everything below the x-axis. So how can we do that? By adding a range restriction or y value restriction. So I'm going to zoom in and think about, okay, what y values, looking at the y-axis, what y values do I want the function to show up for in order to just have quadrant 1, this part, and quadrant 2, this part. So essentially, I only want y values that are greater than 0. So I want to get rid of all of the y values, all of the parts of the function where y is less than 0. So I only want to graph the function here where the y value is greater than 0, or the function is above the 0. Okay, so y is greater than 0. I did it. So now the function only passes through quadrants 1 and 2. Okay. Here it says, I have a cosine graph. It says add a domain restriction. So domain, you can add this in for yourself, is going to be something to do with the x values in row 1 so that the curve stays between the blue segments. So I want to think about what x values do I want to include so that the curve is only graphed between the in between the blue segments. So this time I'm paying attention to the x values because it's domain. And if I look at the blue segment, I'm going to try to figure out what x value is this blue segment. So the x value here is negative 2 pi. A little bit weird, but this is actually a number. So yeah, so pi is just a number. So I get 3.14. So I can use this as part of my restriction. So I want the function to exist for x values greater than negative 2. And then to get the pi, let's see my calculator. Here's negative 2 pi. So I want the function to exist for x values greater than negative 2 pi. So now I can see this part of the function was cut off, which is what I wanted. And then how do I get rid of this other part so that I only have the part left that's in between the blue segments? It's going to be, again, I think it's in the same place. Let me double check. Yeah, it's at positive 2 pi as the x value. So x values to exist for positive 2 pi. Okay, I did it. Now I restricted the domain, or I restricted the x values, so the graph is only graphed between the x values of negative 2 pi and positive 2 pi, between the blue segments. Okay, so this one's a challenge. I'm trying to add domain or range restrictions to these 4 lines so they form the 4 sides of a square. So I only want the square to show up. I want everything else to go away. So I'm going to do a few of them with you, and then I'm going to leave the rest as a challenge to complete. So to begin, let's start by trying to get just this line segment. So this line is x minus y equals 3. And I am going to restrict actually either one would work. I'm going to restrict the domain. So I'm going to say I only want this line to exist between the x value of 0 and the x value of 3. That way I only get this line segment, or only get this piece of the line. So I'm going to say exists between, I want x values greater than 0 and x values less than 3. And there we go. It's starting to look more like a square. Let's do one more together. Let's do this side of the square. And I'm going to say for this one, it's going to be x values between 0 and 3 as well. Let's actually do this one. So for this one, it's going to be x values between negative 3 and 0. I'm looking at the x, so the left coordinate, negative 3 and 0. And that's how I'm going to get that line, is by restricting it so it only is graphed between x values of negative 3 and 0. And there we go. Almost looks like a square. I want you to finish it on your own as a challenge. And that is that for challenge 3. Okay. I'm going to leave this one as well for you to figure out on your own. And that's it. So you're basically just going to be going through finishing challenge 3 and then trying challenge 4 on your own. And that will be it for the Desmos activity today.